So, hello everyone and welcome to this class. This is revision lecture number 2 and we are again going to solve question papers from the previous session. The last class, I think we solved the 3 question papers and that will be our intention in this class as well, to solve at least 3 or 4 question papers. Questions will be random from all the topics, and I hope that this will give you an insight into what your preparations are. Remember, the only way you can make a mistake is if you are doing a calculation mistake or you're doing something in a haste. So be very careful. This is the first question and this is a straightforward one. I think we have already discussed this question when we were discussing all these uh, EM wave radiation or EM wave spectrum. Uses are there, and you have to match the correct one. Which is the correct one? And the correct option is you just have to know one or two of these. If you know one or two of these, you should be able to find out the correct answer. The one I know is X-rays are used for the treatment of cancer. And incidentally, the only choice which has this one is choice number B, and therefore the correct answer is B. Just remember one or two where they are used. If you remember them, then you would be able to find out any answer. Infrared rays are used for physiotherapy. Remember that. UV rays are used for eye surgery, and microwaves are used for aircraft navigation. See, it's a question simply based on your knowledge. If you know it, you know it. If you don't know it, well, you will lose marks on this. Do we understand this?
Yes, sir.
Here comes the next one, which is a pretty simple one. This is, we are discussing 31st Jan paper, shift 2 paper. During an
725.
Great. During an adiabatic process, perform 725 joules of work is done. There is no heat exchange. What is the change in internal energy? So as you can see, the questions, whichever shift I pick up the paper, the question paper are similar and they are as easy as they can get. The only thing they are relying on is whether you remember what you have studied in the class. Third question, same paper. Two balls are projected with speed 40 at an angle 30 and 60 with the horizontal. What is the ratio of maximum height? If you remember the chapter motion in 2D, we had done a lot of questions based on this. What is the ratio? Maximum heights. I'll give you a minute to give me the answer. Option 3, 1 by 3 is correct. Just to give you a revision, the maximum height, the formula is u square sine square theta by 2g, or you can write it as u perpendicular square by 2g. Do we remember this? So the ratio of maximum height h1 by h2 will be equal to sine square theta 1 divided by sine square theta 2. Sine theta 1 is 30, theta 2 is 60. You take the ratios correctly. I always make a mistake in that. I hope you don't. The answer that you will get would be 1 by 3. I hope you understand this. Yes or no?
Yes, sir.
That takes us to the fourth question of the same paper. As you can see, they are in the same category, similar type. And this is the fourth question. I'll give you a minute to give me the answer. Option 2. Ionization energy. When I say ionization energy, it is energy required to move it from the given shell to infinity. The given shell is the second excited state. So ionization energy or the difference in energies would be 13.6 into Z square. What is the Z of lithium?
3, sir.
3 square into the second excited state. N is equal to 3. 1 by 3 square, and then you have to take it to infinity. 1 by infinity square. Let me write it as infinity square, not 0. 1 by 0 does not make sense. And the answer that you are going to get from here is 13.6 electron volts, my dear friends. That is the answer that we were looking at. Try to understand where you are making a mistake and try to correct it in whatever way it is possible. Do we understand this?
Yes, sir.
This is the next question. Question number 5, same paper. We're solving 31st Jan, shift 2. A ball of mass 1 kg is hanging from a 1 meter long inextensible string which can withstand maximum tension of 400 Newton. Tension maximum. If you go back 4 months back, 3 months back, you will find questions that we had done. Find the maximum speed that should be given to the ball, and I'll wait for your answers. Whenever a question comes, we need to take deep breaths. If you don't take deep breaths, you end up with the wrong answer. This is T, this is mg, and I hope you understand that T minus mg is equal to mv square by r. So your T would be equal to mg plus mv square by r. If I want T to be maximum, that will be equal to m into g. M into g is 10. And plus m is 1 into v max square by 1, and this T max is given as 400, my dear friends. From here, if you calculate V max, I don't know how did you get your answers. The answer that I am getting would be root over 390. And that is the answer that we are looking at. Please be careful. If you're not careful, even you are going to make mistakes in the simplest of questions. I'd already given you the formula for everything there. If you go back to that class, you would be able to see how we had discussed this. Shall we move ahead?
Yes, sir.
This is the next one, and it should be a question that should be answered in a few seconds. And I wait for that few seconds. Option 2, you just need to know any one of these. Option 2 is correct. If you know how much is torque, what is the dimension of torque? ml square
T power minus 2.
T minus 2. Stress is nothing but pressure. What is the dimension of stress or pressure? If you understand these two, even then you're not going to get the answer. Pressure gradient is pressure divided by what? Length. So this would be this. Angular momentum is left with the last option, and these are the matching options. As I said, one question you will always find from the chapter on units and dimension, and as you can see, it is always there. Okay, let's move on to the next question, and this is the next one. I'll give you 2 minutes to give me the answer. How are we going to solve this one? We have got two SHMs. And how are you going to get it? Well, this SHM is combined SHM of sine and cos. You can straight away use the formula of sine A plus sine B or cos A plus cos B. Yes or no? Yes or no?
Yes, sir.
So you can, using maths, you can convert this into, I think, 10 sine omega t plus pi by 3. Yes or no?
Yes, sir.
This is your y2. Your y1 becomes the same. Both are same in the same phase. So the amplitude, the phase difference is 0. The amplitude will become 2 times and the answer would be 20. Do you understand this?
Yes, sir.
Chalo, well done. This is the next one and I'll give you a minute to do this. So how are we supposed to do this? 80 meters is the correct answer. We have already discussed the maximum height. You just have to use the formula and get your answer. Yes or no?
Yes, sir.
Shall I do it or you are able to do it?
We have done it.
Chalo, then we will move ahead. Oops. We'll move ahead into the next question. And the next question is this one. A body has a weight W on Earth. Find the weight at a height 9 times the radius of Earth. How are you supposed to do this? Remember, the height is given as 9 times. So the distance from the center of Earth becomes how much?
10 times.
10 times. So remember the value of G is Gm by R square, where R is the distance from the center of Earth. So G dash will become Gm by 10R square. Yes or no?
Yes.
So the answer has to be W by 100, my dear friends. The mass remains constant. Just have to find out the variation in the value of G, my dear friends. And that is how you end up with your answer. Let us move on to the next one. And the next one looks like this. A wire is first coiled in N circular terms and carry current I. Same wire is again coiled in capital N. Same current I. Ratio of magnetic fields. Take a deep breath and solve it. Take some time, think about it, and then give me the answer. Now remember, you must understand that for a circular coil, magnetic field is mu naught Ni by 2R. Yes or no?
Yes, sir.
where n is the number of turns and r is the radius of the coil. Now, in this case, the radius of the coil r1 will be L divided by
2 pi n, sir.
2 pi n. Similarly, R2 will be equal to L divided by 2 pi capital N. One N is already there, one N is going to come. So I can say magnetic field here will be proportional to N square, and therefore your option has to be option 2 and not anything else. Do we understand this?
Yes, sir.
Okay. Let us move on to the next one. This is the next one. I'll give you 2 minutes to give me the answer. Speed of sound. Young's modulus divided by density. Yes or no?
Yes, sir.
Just need to put the formula, get the answer, and stay happy. Moving on to the next question. Question number 12. Same paper. And this is the question: when a current of 4 amperes is made to run in a resistance of R ohm for 10 seconds, heat is H. 16 amperes, same resistance, 10 seconds. Heat dissipated in a resistor delta Q or delta H is I square RT. Time is same. It is directly proportional to current square. Current has become 4 times, so the heat will become 16 times. And that is the answer, my dear friends, that we are looking at. As I can see, you just need to remember simple things, which should not be hard. This will also give you an indication of what you want to revise, what you have to revise, and how you have to revise. Moving on, this is the next question. I'll give you 2 minutes to tackle this one. Option 4, XL is equal to omega L. Everything is given. Omega is 100 pi. You just have to multiply it. L is 5 millihenry. Just multiply this. If you multiply this, you must end up with the first option. This is the next question. I'll give you a minute to solve this. This is a question on voltage sensitivity. I hope you remember the formula. Now remember, the current sensitivity is current, the deflection per unit current, and the formula was N A B by K, where N was the number of turns, A was the area of the coil, B was the magnetic field, and K was the galvanometer constant. The voltage sensitivity was delta divided by V, deflection per unit volt. This was K into R. These are the two basic formulae that we had to remember. Now what is given here? Number of turns in the coil are increased. So number of turns are increased. If the number of turns in the coil are increased, that means you are putting more turns in the coil. I am assuming that the area of the coil remains constant and you are putting more turns. That means you are putting more coil. If you are increasing the number of turns, you are also increasing the resistance. Yes or no?
Yes, sir.
If The resistance of one turn is, let us say, R. If you put more coils, it will become N times. So the current sensitivity is increased by increasing the number of turns in the coil. So N will increase at the same time. Whatever N has increased, the same increase will be there in the resistance. Yes or no?
Yes, sir.
If I increase 5 turns, the resistance will also become 5 times. If I increase 10 turns, the resistance will also become 10 times. So they will cancel out each other. Yes or no?
Yes, sir.
So the voltage sensitivity will remain unchanged. There will not be any change in the voltage sensitivity. Do we understand this?
Yes, sir.
That brings us to the next question. And the next question is a question from the second section. So you have to give the answer in the correct scientific notation. And this is the first question. RLC circuit, R is given, L is given, C is given. Find out the peak current, remember. So we have to find the impedance of this circuit. It will be equal to under root of R square plus XL is more, XC is less, XL minus XC the whole square. R is 10, R is 80, XL minus XC is 60. So the impedance becomes 100 ohms. The peak value of current I naught will be equal to V naught. V naught is 2500 divided by 100. So the answer is 25.00. I don't understand why it was taking so much time. You don't understand our question?
Understood, sir.
Why was it such a difficult calculation that you took 5 minutes to just do the calculation? Anyways, the next question, this came in your first attempt, first session. And the same question we had done in the class. Anyways, two discs of same mass, radii R1, R2, thickness 1 mm and 0.5 mm, have density in the ratio 3:1. What is the ratio of their moment of inertia about any diameter? That is correct. Now, the masses of both the discs are equal, right?
Yes, sir.
M1 is equal to M2, so pi R1 square into thickness T1 will be equal to pi R2 square into thickness T2. Yes or no?
You have
Yes or no?
forgot into row.
Into row, yes. Row 1, row 2. Yes or no?
Yes, sir.
Now, we know the ratio of the densities R1, row 1, row 2, the ratio of their thickness. From there, you can find out the ratio of their radius square, R1 square by R2 square. Yes or no?
Yes, sir.
And R1 square by R2 square is going to come as 1 by 6. Mass is the same. So about the diameter for a disc, it is 1 by 4 mr square. Yes or no?
Yes, sir.
So it is proportional to r square. The ratio is coming as 6. So the answer is 06.00. Do we understand this?
Yes, sir.
Remember this? Remember almost everything that can come, not almost, everything that can come, we have covered it in the class. We are just doing the question so that you understand the same things are going to come, what you need to remember and what you need to revise. This is the next question. A body is moving with something, friction, it stops. What is the value of x? Coefficient of friction is x by 5. Simple question. I'll give you 2 minutes to give me the answer. Yes, what is the answer?
02.00.
02.00. V is equal to U plus AT. Final velocity is 0. Initial velocity is given. Time is given. You will get the value of A, and A is nothing but equal to mu G. From there, you will be able to find out the value of mu. And I think it is coming as, the value of mu is coming as how much?
2/5, sir.
2 by 5. So the answer is 02.00, and this is the way you have to write it down. I hope we have understood this.
Yes, sir.
This is the next question. And if you see this question, you will remember that we had done, and I had given you the general formula for this question as well. Do you remember this? Well, it's the time now to use it. Well done. The ball was dropped from 20 meters from out. Find the height up to which it rises. You can use, I think I had given you the general formula. Yes or no?
Yes, sir.
H dash will be equal to e raised to the power n times of h. Yes or no?
Yes, sir.
So here, what is the, sorry, e raised to the power 2n times. Yes or no? I forget,
Yes,
2n.
sir.
2n times h. Here n is equal to 1. So it will become e square into h. Yes or no?
Yes, sir.
And e square is 1 by 4 into 20. The answer will be 5. So it is 05.00. That is the answer that we are looking at. This is the next one. I'll give you a minute to solve this. 2 root 2 will be the displacement. How did you get this?
Sir, I have found omega equals to V by R. There I have found out that velocity. Sir, sorry, omega equals to 2 pi by t. I have found out omega, and I have found out this theta equals to omega into t.
So,
Sorry, sir, I have taken time as 2 seconds.
what is the answer? I'm still awaiting the answer. I did not see any answer there. I'll give you 1 more minute to solve it then. Remember, if you cannot solve a question in 2 to 3 minutes in the examination hall, you just leave it. Because then you are not going to solve it. You will not be able to solve it because you will get trapped. So, if you cannot solve a question in 2 minutes, leave it. Just leave it and move ahead in life. This is a circle. The particle is moving in a uniform circular motion. Yes or no? It is moving in uniform circular motion. The time period is 4 seconds. Common sense you can use. If I start from here, that time is equal to 0. 1 second it will be here, 2 seconds it will be here, 3 seconds will be here. It starts from here. It reaches here after 3 seconds. What is the displacement? This is R. This is R. The displacement is root 2 R. R is given as root 2. The answer is 2. 2.00. I don't know what you were doing or what you were thinking. Remember, any question that comes in the examination hall, it has to be solved in 1 or 2 minutes, not even 2 minutes. You don't even have 2 minutes to solve each and every question. If you cannot do it in 2 minutes, leave it, because you will not be able to do it and you will mess up the entire paper for that single simple question. Do we understand this?
Yes.
The question that is going to come in your examination hall is going to be as simple as possible. You must realize it that it has to be a simple question. I'll give you 2 minutes for this one. Let's see if you can do this one. And I think we did this question in wave optics. This is the screen from 3 days ago. 3 days before, when we were doing wave optics, this is what we did. This, my dear friend, is the screen now. If you can't do it, if you can't replicate the same question after 3 days, well, I can't comment much on it. Anyways, N1 maxima, N1 lambda 1 d by d is matching with the N2 number of maxima of the second one. From here, lambda 1 and lambda 2, you can say 6 times N1 will be equal to 8 times of N2. N1 by N2, the ratio will be 4 by 3. Once you get the value of N1 as 4, you can put it in this equation, or N2 as 3, you can put it in this equation, and you end up with an answer. The minimum separation will be N1 lambda 1 d by d, or N2 lambda 2 d by d. The answer that you're going to get, it's not going to change. 3 days ago also it was 48. Now also it is 48. 48.00 is what I would call it, because this is the way in which you have to write it. With this, we come to an end for this particular paper. We move on our attention to the next paper. This is 24th Jan paper, shift 1. And I hope we can do better here. You can always improve. This is the first question taken from this paper. The equation of a wave is given by this. What is the velocity of the wave? You have 2 minutes to give me the answer. One is correct. You can compare this equation with the standard equation. This will be k, this will be omega. The speed of the wave v is given by omega by k. Yes or no? You will end up with the answer 2 meter per second. Do we understand this?
Yes.
Let us move on to the next one. This is the next one. And I think I gave you a formula for that as well. Two charges Q1 and Q2 are separated by a distance t in a medium of dielectric constant k. If they are placed in air, then find the equivalent distance at which they experience the same force. When they are placed in a dielectric, the force in the dielectric will be Q1, Q2 by 4 pi epsilon naught K into D square. When they are placed in air, the force will be Q1, Q2 by 4 pi epsilon naught into R square. The two forces have to be same. So your R square will be equal to K into D square, or your R will be equal to D into under root of K. I hope you understand this. Do we understand this?
Yes, sir.
That takes us to the next question. It can't get easier than this. This is the next one. I'll give you a minute to give me the answer. Momentum is equal to under root of,
2 KE into M.
yes. So under root of 2 into mass is 24 into 1000. So you will get this as 220 root 10. It does not match any option. Maybe there is some printing mistake somewhere. Anyways, do you understand this?
Yes, sir.
Okay. Let us move on to the next question. This is the next one. A particle is projected vertically upwards, reaches 136 meter. What will be the maximum range for the particle with the same speed? When you throw a ball vertically upwards, the maximum height is u square by 2g. Yes or no?
Yes, sir.
Maximum range u square sine, u square sine 2 theta by g, theta becoming 45 degree. Maximum range is u square by g. So range is 2 times. I don't know what you were doing. Range is 2 times the maximum height. Multiplied by 2 and you can land up with your answer. You've taken eons to give me the answer. Not a good sign, my dear friend. Taken too much of time to solve a question which should not have taken 3 to 4 seconds. Solving this paper will give you an insight on where and what type of questions you must practice. 6 days from now, 7 days from now, you are going to appear in your exam. This is the next question. So, what is the formula of time period for a spring pendulum? My body attached to a spring. Do we remember this? What was the formula? No one remembers it?
Under root K by M, sir. Or M by.
2 pi under root m by k. 2 pi under root, mass is 2. What is the k here?
K is 40, sir.
40, sir. That is correct, sir. I don't know from where you are getting to. There are sometimes there are interdimension portals that open, and from those interdimensional portals, funny answers come. But if we remain in reality without opening any portal, the answer is 5. That tells us that we must not open interdimensional portals. Questions are simple, that can be done by physics that we know and not by quantum physics or interdimensional or alien science. It has to be done by what we know. Find the tension in the string. If such a question comes, remember, it might require some time. The force which is pulling here is how much?
mg sine 30, sir.
So 40 sine 30 is how much? 40
1
by 2. And the force which is pulling here is 10 sine 60. So it is 5 root 3. Yes or no? So it will go this side. Acceleration will be this side. And what will be the acceleration? 20 minus 5 root 3 divided by 5. Yes or no?
Yes, sir.
So this will be 4 minus root 3. Do we understand this?
Yes.
Now I can make the equation for this block, and from there I will get the tension. What is the equation of this block? mg sine 30, which is 20 minus t will be equal to 4 into a. A is 4 minus root 3. Yes or no?
Yes, sir.
Once you calculate t from here, I think all the options are looking similar. Forget about that. I think the answer that you are going to get is this one. The options are looking similar. A printing error. Do we understand this?
Yes, sir.
Sure?
Yes, sir.
Don't look at the option. The option may be not correct. I got this made, and I think the options I did not check. Anyways, this is the one. You have to find out the value of x. So this is a question from the second section. So this is a solid sphere. About this axis, the moment of inertia is 2 by 5 mr square. So about this axis, what will be the moment of inertia?
2 by 5 mr square plus mr 4 mr square.
If you add this, what you will get?
22 mr square by 5.
22 mr square by 5. That must be equal to mk square. Ting, 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 ting. So k is under root of 22 by 5. So into r. So I can write it as under root of 110 into r by 5. So my dear friends, the answer is not 22. The answer is 110. And both the options would be given if the question came in multiple choice. 110 is the answer. The only way you are going to lose points in the JEE that you are going to give is by things like this, your maths, your calculations, and it's an never ending problem which has been discussed in details many times. Anyways, you can always blame something or the other. You have to blame yourself at the end of the day. You can't do calculations of this nature. This is the next one. In a hydrogen atom, first line of Paschen series is 720. Find out the second line of the same series. So how are we supposed to do this? Lambda is proportional to 1 by n1 square minus 1 by n2 square. Do we remember this?
Yes.
For the first line of, remember, Paschen series, what are the values? 1 by 3 square is 9 minus 1 by 16, 4 square. For the second wavelength, this will be proportional to, this will be 1 by 9, but this will become 1 by 25. Do we understand this?
Yes.
That is what you needed to find out. Now I can take the ratio lambda 1 by lambda 2. And again, if you make a mistake in finding out the ratios, you will end up in problem. So on the top, you will have 25 minus 9. 25 minus 9 is how much? 16. 16 divided by 9 into 25 divided by, then 16 minus 9, I think is 7. 7 divided by 9 into 16. 9 and 9 will get cancelled. And I think you will get 16 into 16 is 256 into 25 divided by 7. Are you getting this? Or have I done a mistake?
Sir, it is 256 by 7 into 25.
That is what I have written, no?
256 by 25 into 7. 25 is
Oh,
in
yes,
the
yes, yes. Yes. Sorry. See, I always make a mistake in taking ratios. 7 into 25. So your lambda
2 will be
lambda 2
into 25 by
lambda 2 will be equal to lambda 1, which is 720 into 7 into 25 divided by 256. You can just cut this by 10. You can cut this by this. So it will be 72 multiplied by 7. I don't think any option is matching that one. Yes or no?
Yes, sir.
That is the answer. You just have to remember these simple things. We get this. Don't worry about the answer. Just worry about how the question is to be solved. The answer may not match because we don't get the papers. We are just making the papers from whatever feedback we get from the students. Okay. This is the next one. I'll give you 2 minutes to give me the answer. 2 root 2 is correct. Magnetic field at the center. Mu naught I by 2R. Magnetic field at any point on the axis. Yesterday also I gave you the formula. Mu naught I R square upon 2 times R square plus X square raised to the power 3 by 2. X is equal to R here. Yes or no?
Yes, sir.
To find out the ratio, you will get 2 root 2 from there. Shall we move ahead?
Yes, sir.
This is the next one, and I hope that you can give me the correct answer. Take your time, give me the correct answer. Length of the wire is same. You can take one wire as infinite wire, the other wire as a portion of the wire. The formula of force will be I into L into B. L is constant. So force is proportional to I into B. Force is proportional to I into B is mu naught I by 2 pi r. From here I can get force is proportional to I square by r. My dear friends, distance is halved. Current is doubled. I do not know how do you get 2. The answer that I am going to get, distance is halved, current is doubled. The answer that I am going to get is not 2, not 4, but 8. Remember what questions you're not able to do now. The way you revise is you go back to the same topic, see the formula that we had done, see the question that we have done, solve one or two questions, and then we will be good enough. And that is the reason we are doing random questions. Instead of taking random questions, I am just taking questions from the paper that has happened. So it gives you an idea of how the paper is, how it is balanced, how many questions are numerical, how many questions are theoretical, one assertion and reasoning we have seen, one question and units and dimension we have seen. This is the next one. You'll get an idea of the question that you're going to see in your exam. 2 minutes you have, and I hope you don't disappoint me this time. And option 2 is correct. This is a case where magnetic field is varying with time. Do we remember this? So the induced EMF will be A into dB by dt. We understand this?
Yes, sir.
Area will be pi
100.
into R square. R square is this multiplied by the range. So decreases from 0.5 t to 0 in 0.5 seconds. 0.5 divided by 0.5, that will be the average EMF, and that will be your answer. And the option that matches this is 10 millivolt. Do you understand this?
Yes, sir.
Here we have found out the average EMF, and we assume that the rate is same. So whatever the average EMF, that will be the EMF at 0.25 seconds. We understand this?
Yes, sir.
This is this question. Be prepared. Such questions would be coming. Statement, assertion, and reasoning. This is the one. Light incident from air to water. Brewster angle is theta b. If light is incident from water to air, then the Brewster angle is 90 minus b. When light goes away from air to any medium of refractive index, the Brewster angle is given by tan inverse mu. Give you a minute to give me the answer for this one. I don't know from where it is coming, but if you remember, this is the snapshot taken from the class that we did 3 days back. Brewster law, mu is equal to tan IP. That is the statement number 2. So statement number 2 is correct. Now, if this angle is I, which is Brewster angle, both the light, the reflected one and the refracted one are at 90 degrees. So the angle of refraction R becomes 90 minus this angle I, which is the Brewster angle. So if it is going from air to water, if the Brewster angle is theta, when it comes from water to air, the Brewster angle will be 90 minus theta. You can note this down. Brewster angle from air to any other medium, if the Brewster angle, polarization angle is theta p, then from that medium to air, the Brewster angle will be 90 minus theta p. Noted it down?
Yes, sir.
What is the correct option? The correct option is option 1. Both the statement are true, and statement 2 is the correct reason of statement number 1. Do you understand this?
Yes, sir.
This is the next question, and I hope that you can give me an answer fast. So how are we supposed to do this? Between the two ends, the distance is rho L by A. You just put the values. Resistivity is 2.4 into 10 raised to the power minus 5. Length is 3.14 meter. The area of cross section will be pi r2 square minus r1 square. The outer radius is given as 4 mm, 4 square. Inner radius is given as 2 mm, 2 square, multiplied by 10 raised to the power of minus 6. Pi and pi will get cancelled. Whatever you get would be your answer. 16 minus 4
It is
is
2.
2. I don't know why you had taken so long to calculate this.
Sir, we have already said this answer 5 minutes before.
Okay, then probably I was not able to hear you out. Maybe I put my thing on mute. I was not able to hear you out. Anyways, this is the next one. Weight of an object on Earth is 18 Newton. Find out the weight at the height 32 kilometers from the surface of Earth. Remember, the radius of Earth is 6400 kilometers. 8 newtons, I think, is the correct answer. Again, you just have to find out the value of G. You know G, Gm by r square. On Earth, it will be Gm by r square at a height of 3200 kilometers, which is r plus r by 2. 3r by 2, yes or no?
Yes.
The value of G dash, Gm by 3, r by 2 square. So it becomes 9r square by 4, or your G dash becomes 4 by 9 times the value of G. So it simply becomes the value of G becomes 4 by 9 times. So the weight also becomes 4 by 9 times, and the answer you will get would be 4 multiplied by 2, and that would be 8 newtons. Do you understand this?
Yes, sir.
This is the next question, and I hope can give an answer quickly. For this one, we have done a lot of questions on this type. Find the values of current I4 and I5. Option 2 is correct. 8 by 5 and 2 by 5. You can very easily find out this. You can find out the total resistance. What is the total resistance coming?
Total resistance is 11.
11? 1 plus 3, 4. 4 plus 1.
Sorry, 12, sir. 12.
12. So the current will be 2 amperes. Current divides in inverse ratio. So in 5 ohm, it will be 2 multiplied by 20 divided by 5. And in 20 ohms, it will be 2 multiplied by 5 divided by 25. Yes or no?
Yes, sir.
So the answer that you will get would be in this thing. Yes or no?
Yes, sir.
Next one. This one.
Statement two is true.
I think there is something wrong with this question. The statement 2 is correct. Do we understand this? There is, I think, some mistake in the first statement. I will give you the next question, and then I will probably see what is the correct one. Okay, just check it out. This one, it's a question, my favorite topic, units and dimension. I'll give you a minute to give me the answer. Option 1 is correct. You don't need to calculate everything. You just need to calculate what you know. Planck's constant, I told you how to calculate this. Momentum, you know. Stopping potential, it's potential, so it has to be connected to this ampere work function. Even if you don't want to calculate this, after calculating one or two, you would be able to find out. Momentum is easy to calculate, yes or no?
Yes, sir.
So once you calculate momentum, it would become easier for you to calculate the other ones. Do we understand this?
Yes, sir.
Okay. As said, I will just put the correct question here, and this is the question. Language of that question was wrong. Put the correct one here, and this is the correct one. Now you can give me the answer. Yes. What is the answer here? Photodiodes are operated in reverse bias. Current in forward bias is more than the reverse bias in a PN diode. Which option is correct?
Option A. Option A, sir.
Option A. Photodiodes are operated in reverse bias and current in forward bias is always more than the reverse bias. Do we understand this?
Yes, sir.
Great. Then this is the next one, and I hope you can give an answer quickly. Propagation vector, the direction in which the wave is propagating an electric field. Omega is the angular frequency. Then what is the value of the magnetic field? Give you a minute to give me the answer. Omega, E and B, yes or no?
Yes, sir.
What was the relation? E is equal to B omega. Do we remember that relation?
Yes, sir.
The direction of propagation is given by K cross E. So remember, the correct option is this one. I gave you a lot of questions on this electromagnetic waves. Do we remember this?
Yes, sir.
Okay. And then the next one. This one. The temperature of a gas is increased from minus 73 to 527. RMS velocity becomes double. Product of pressure and volume is equal to the translational kinetic energy. Option 1 is true and 2 is false. That is correct. The RMS speed is equal to under root of 3 RT by M. Yes or no?
Yes, sir.
In first case, the temperature is 200 Kelvin. In the second case, it is 800 Kelvin. Yes or no?
Yes, sir.
So the temperature has become 4 times, so RMS speed will become doubled. This option is correct. Remember, the transitional kinetic energy is given by 3 by 2 PV. So it has to be multiplied by 3 and divided by 2. Statement 2 is wrong. Statement 1 is correct. Do you understand this?
Yes, sir.
Sorry. Yeah. Statement 2 is wrong and statement 1 is correct. I thought that I have said the opposite one. This one. The ratio of quality factor and bandwidth. This is just to remind you that question of this nature can come. If you don't remember what is bandwidth, if you don't remember what is quality factor, you will not be able to solve this. Anyways, bandwidth given by R by L. Quality factor. I've given you many formulae. This is one of those formula. Just have to find out and get the answer from this quality factor divided by bandwidth. Quality factor, when you put the values, I think you are going to get 200. Bandwidth, when you are going to put the values, you are going to get 25. So the ratio is 8. 08.00 is the answer that we were looking at. Noted it down?
Yes.
This is the next one, and I hope that you can give me an answer straight away. Some sequence is given. You are supposed to find out the product. Option 2, sir, is correct, sir. When an alpha decay occurs, the mass number decreases by 2. So mass number will decrease by 2. The mass number will decrease by 4. And there are 2 alpha decays, so the mass number will come down by 8. Yes or no?
Yes.
So either option 1 or 2 or 4 all are correct. Now you have to see what is the difference in the number of electrons and protons. Yes or no? From charge conservation you can find out that in a beta minus decay it goes down by 1, beta plus decay it comes up by 1, and in alpha decay it goes down by 2. Yes or no?
Yes.
So it will go down by 4, it will come up by 1, it will go down by 1, and therefore the answer remains option 2. Do we understand this?
So what happens in gamma decay?
What happens in gamma decay? Go back to the class and see what happens in gamma decay. What happens in gamma decay? Forgot gamma decay? What is happening? I hope you have made notes. Did you make notes of modern physics? Did you make notes of modern physics? This was alpha decay. Mass number goes down by 4. Atomic number goes down by 2. Beta decay. Mass number remains same. Atomic number goes down by 1. Beta minus decay. Mass number remains same. Atomic number increases by 1. Gamma decay. When you have an alpha or a beta decay, the nucleus that is formed may not be in its ground state. So, from its ground state, from its excited state, it may jump into its ground state by emitting radiations and that radiations are known as gamma radiation. Do we understand this? Do we understand this? Are we there in the class? I hope you have understood what I am saying here.
Yes, sir.
Remember the types of decays. You might have a question on this. Alpha decay, beta decay. Beta decay are of two types, beta minus, beta plus. And then there is gamma decay. Shall we move on?
Yes, sir.
Do we remember this? No doubts?
Yes, sir.
This is the next problem. Choose the correct option. I'll give you a minute to give me the answer.
Option 2, sir.
Option 2, sir. Thank God, sir, that we got it. It is explained by wave theory. Intensity only changes the saturation current. Remember this?
Yes, sir.
Frequency of radiation changes the stopping potential. Remember this?
Yes, sir.
This is the next one, and you have 1 minute to give me the answer. X is 1, it is correct. You just have to take the dot product. This will be dotted with this. This will be dotted with this. This will be dotted with this. From there, I think you are going to get the value of A as 1 and B as 2. Yes or no?
Yes.
Everyone got this?
Yes, sir.
Okay. We are doing questions. Okay, this is done. This is done. Also done. This one. A uniform rectangular plate has a circular hole of diameter d. The coefficient of linear expansion of the plate is alpha. Find the change in the diameter. Option A, 2d alpha delta theta. How did you get it?
Sir, if linear expansion coefficient is alpha, then areal expansion coefficient is 2 alpha. No?
But here they are asking the change in diameter.
Sir, change in diameter we can treat as changing from two sides, so it will be
As I
two
told
times
you,
of
it
alpha
expands
diameter.
in length. So the correct option is this one only. Remember this.
Sir, how it is?
We are not talking about area expansion. If it was area expansion, how much is the change in area? It will be 2 times A into alpha into delta T. This is linear expansion only. Change in diameter is linear expansion only. Okay. Whether it is radius, okay. You take a rod of length L, take it as radius. You take a rod of length 2L. Does the rod of length 2L get expanded 2 times more than the half rod? The ratio remains same, no?
Yes.
Whatever this rod will expand, the same in the same ratio the other rod will expand. Since the length is 2 times, that does not mean that this going to the ratio will change, and if this expands by 25%, that will expand by 50%. Does that happen that way? Do you understand what I'm saying?
Yes, sir.
The ratio of expansion remains same because alpha remains same. You understand this?
Yes, sir.
Okay. This is done. This is done. This one. I think we did a similar question. May not be in electrostatics. We might have done in gravitation. If not in gravitation, we might have done it in electrostatics. Doesn't matter. The question remains same. Two charges plus q and minus q are released on the situation. Kinetic energy of the system when the separation becomes half. 2 minutes you have. This, I think, it's probably the last question. Now, one more question is left. Do it fast. You just have to apply law of conservation of mechanical energy. Do we understand this? Mechanical energy at R should be equal to mechanical energy at R by 2. Do we understand this?
Yes, sir.
In first case, what is the mechanical energy?
It is
Minus 1 by 4. Let us take it as minus K. Minus K Q square by R square. Yes or no?
yes, sir.
R square or R? KQ square by R.
R only, no, sir. Like only potential energy exists.
Yes. In second case, it becomes minus KQ square by R by 2. Yes or no?
Yes, sir.
Plus the kinetic energy of the system, right? Let me write it the kinetic energy of system. That will include the kinetic energy of the first plus the kinetic energy of the second. Yes or no?
Yes, sir.
What is the kinetic energy of the system? Coming from this, it will be coming as kq square by r. Yes or no?
Yes, sir.
So what is the value of n?
1, sir.
1, sir, and that is the answer, sir. Do we understand this, sir?
Yes, sir.
Pakka, sir?
Yes, sir.
Last question from this. And this is the question. You have 2 minutes to give me the answer and stay happy always.
Option.
Oops, where is my pen? Just a moment. Which is the correct option?
Sir?
What is the correct option?
Option C.
Option C. If it is going up with uniform velocity, acceleration is 0, T must be equal to mg. If it is coming down, the reaction force is decreased with an acceleration. If it is going up with an acceleration, the reaction force is increased. We understand this pseudo force?
Yes, sir.
That brings us to an end of this particular revision session. We have covered a lot of questions from different sessions. Remember, similar question, similar pattern, just maybe different in values. These questions are going to come in your exam. The way to do revision is, if you're not able to solve one particular question, by solving I mean, if you do a calculation mistake, I can't help you on this. If you don't remember any formula, just in the case of bandwidth and Q factor, you forgot the formula, you go back, look at this formula, do 2 or 3 questions, and that is the way to do revision. Do we understand this?
Yes, sir.
Next class tomorrow, we will do more questions on this and we'll keep on doing these questions. If you can do, remember, you just have to do 15 or 18 questions. If you do 20 correct questions, you are in 99 percentile. Maybe 99.4 also. Just have to do 20 correct questions. And you can see out of this 30, you can easily do 20. Yes or no?
Yes, sir.
So I'll see you in the next class. Take care. If you have any doubts, please come up. Class is over from my side. Take care.